And so I was a bad YouTube video producer, and I did not actually take pictures of moving the lathe onto the pallet. As you can see, it's 2x4s screwed in on the top and then towards the bottom. Here you can see there are 2x4s that are cut in, and those are pressure treated to hold the pallet together on the bottom side. And so now you can really see how big it is. The stand is 30 inches by 6 foot, and right now I have it sitting on the engine hoist. We will probably end up changing that. And the interesting conundrum I have is the gentleman who was supposed to move it, turns out he's a contractor and doesn't have insurance when push came to shove. So now I'm trying to see what other options I'll have and some thoughts. We'll have to see how they go. Or is there a possibility of attaching wheels to this somehow and then using that to move it down? Some of the things I'd like to try and keep, we'll see, is these badges. And then the only other thing really left to do is order the JB weld for the top casing, start working out how we're going to do the various selector rods, and start working out how to power the VFD. So for this video, I wanted to do a short, it'll be really short, video about the electrical system on the Storebro Bruk lathe. And so here you can see there's a dial switch, and all of these wires, well, not all of them, but a large number of them run to two places. One is either the switch on the back side, and that switch is operated via this selector rod. So there we have off, there's reverse, neutral, or off, and then forward. So that's actually one of the features I'm planning on keeping when I go to the VFD. But this switch here, natively, and I'm not sure if this is the native switch, but it was the 2-speed switch. So you would have 0, 1, or 2 as your speed selections. So that, I believe that has 3, 4, 5, 6, 7, 8, 9 wires running to it. One thing I'm seeing with this lathe is it loves wires. So then we go down to this control box, and this is, in essence, the connector between the wires up here. Some of them run down here, and then other ones run or via this conduit that's slightly off frame. They run via the conduit to the back section. And lastly, you can see there's a small conduit here. This ran in as well previously, and I believe that runs from the motor. So now I'm going to take you around back, and here we can see the back of the motor with what I believe is the main unit. So here you can see the wiring diagram. You have your Y and your delta, and right now my thoughts are I'm going to run it to delta. Since I'm using a VFD, I can control the speed. We'll have to see how that goes. And that smaller casing wire just runs over and then to the ACEA 3 to 5 0.5 horsepower motor. And so, in case anyone wants to see, let's get lower, and so we can take a look at all the wire channels. So that's the inside connector of the motor. Since we're here, we'll take a quick look at the data plate, should anyone be interested in that. Okay. This model came with a light that I'm not sure if it was a factory light or not, but here you can see it's an overhead light. It doesn't wire into the lathe, it's just powered by a lamp cable and a, here it is, conventional 120 volt power. And then lastly, and this is something that will end up getting removed, is the selector switch. The selector switch is a pretty burly thing. It has 2, 4, 6 wires run to it. And what they really do is it's an old-fashioned contactor switch. You can see when we're forward, this one's open, closed, closed. When we're in neutral, everything is open. And then when we are in reverse, we are closed, open, closed. So my plan is to keep the switch. I like the idea. And I'm going to run my VFD's signal wires to this. I may also run them to an external panel for an e-stop. Still have to do a bit of thinking about that. If you have any thoughts or any ideas, I would appreciate them. Feel free to put those in the comments. That's a look at the electrical system as it is today. Here's a look at the VFD, the Automation Direct. It's a pretty cool unit. You can see you have the ability to remotely mount the faceplate should you want to. You just buy an extension cord, which is pretty cool. Definitely thought about doing that. And it's also got the built-in potentiometer for your frequency. And on the drive side, you can see here, let's try to get a better look. You have your terminal blocks. So T1, T2, T3 is going to be run straight to our motor on the various phases. Brake, B1 and B2, we're not going to run those day one. I'm going to see how much native braking the VFD will handle. If it's not enough, we'll go buy the resistor and run the resistor between B1 and B2. It's about a $70 option. And then what we're going to end up doing is using the 10 volts and one of the inputs, probably D1, D11 and D12, for our start and stop, or sorry, forward and reverse. And so we'll do that in the future. The switch we have here is a motor disconnect, but what I'm going to do is I'm going to use that as a disconnect from the power before we get to the VFD. And then lastly, on the line side you have your L1, L2, L3. And so what we will most likely do, since we only have 2 phases to come in, we'll use L1 and L2 and the ground, obviously. So that's a look at what we're planning on doing using Automation Direct VFD. And I will update that. I think day one we will probably use the standard potentiometer on the face, but in the future we may branch out to an e-stop button and a relay remote potentiometer. So if you have any questions, thoughts, concerns, put them in the comments. I'd appreciate them.